Welcome back guys. I have apology for this long break between videos because I got stuck in some of the academic stuffs and now I am free to concentrate on this course. So, in the previous video is get the essentials for knowing the basic things which get happens at hardware level, and if you haven't watched that video then go and watch it now for better understanding of all the processes. So for what we are waiting for, let's jump off to our first hack of the series. For performing the task of reverse engineering, we need something called Debugger, which is similar to disassembler which we have discussed in a previous video, but with extra additional features, that is, it allows users to view and change the running state of software or program. There are various types of debuggers available in the market, but in this course we use GNU's GDB debugger, and in future videos we will use x32 and x64 debugger for more complex Windows type applications and softwares. I have put down the link for installation of GDB in the description below. Now, we are going to write our own assembly code and exploit it, because exploiting our own code will give better understanding of all the process which is going on. I'm writing here a code and I think you all are getting what is going on here, because the basic syntax of assembly has already been discussed in the previous videos. So these codes does nothing, just move the data to the registers. Here NOP is an assembly instruction which does nothing, and I marked it here only for doing nothing. I named a label as moving data into registers, which will be visible to us for identifying the code in the phase of exploitation of code, which is below this, and the code here moves the value 100 into EAX register. And code of this exit label has been discussed in the part 3 of this series, so go and watch it again to get more clear. Now, after writing code, we need to compile this code using NetWide assembler. Here ELF32 generates object code file for 32-bit system, and after generating object code files, we need to pass it to the linker for creating in the format of our desirable executable. Here I converted it into exe format. Now you have your first computer program which is built using assembly, and when you click on it, then you get to know that it does nothing. Don't worry, this program already doesn't supposed to do anything. This just moves the value 100 into the EAX register at hardware level. Now we have created our own program for exploitation of it, and we are eligible to perform the task of reverse engineering on our created software. So our main task is to identify and change the value 100 to some other value which is going into this EAX register. Here GDB debugger plays its role. To load our executable into debugger, we just need to mention our name of executable with GDB command in a terminal. Then set a breakpoint at start level by mentioning B just before start. Setting breakpoint allows us to examine the internal state of program by stopping the flow of program at that instance of time. Now run the program by typing R command in the GDB terminal. In the above step, we have marked a breakpoint on start. So after running, our program will stop at breakpoint, and if we disassemble our program at this point by typing disas command, then it will display the NOP instruction which indicates that we correctly get hit at start level due to a breakpoint. Now we need to execute one instruction at a time, because our moving data into registered label is just after this start label. So for that we execute each line one by one by typing si command. If we do that, then we will see our program started entering into moving data into register label by typing disas. We see that this number is the hex form of 100 and is going to move into EAX register. And if we type si again, then it will be executed, and to see the internal state of all the registers we type IR with a space between them. Then it will show that 100 is stored into EAX register. Now our hacking parts comes in. We just have to change the value which is inside this EAX register, that is 100, to some other value. So for that, type set $EAX is equal to 200 and then type enter, and boom, your work has been done. You just hacked your first program by using the skills of reverse engineering. If you're gonna see the values inside this, then it will display your manipulated value. So this is how manipulation of software works at hardware level. And from these basic applications, you get the basic stuffs of the reverse engineering. And in the next video, we will do some more complicated stuffs and try to dive deep into this. So that's all for this video. We will meet you soon in part 7. Until then, cheers.